Hello everyone, and today we're talking about exponential growth. And here's the first question. In 2005, there were 1,000 rabbits on an island. The population grows 8% every year. At this rate, how many rabbits would there be on the island by 2020? So the formula that we use for exponential growth is this, where A is the initial number and B is like the increase, like rate, and basically it's like 1 plus rate, 1 every year, but like the number is the year, and x is like the time basically. However, we kind of change, we make it into RA, 1 plus R, because of each year. But if it says every 2 years, blah blah blah, that's when you do the stuff. And then time. So we know that the initial is 1,000 population, then 1 plus 0.08, because that's like decimals 8%, and then how much years? Well, look, 15, because the difference between these years is 15. So, and the answer of this is 3,172. So right now we're basically decreasing. So the formula is gonna be like similar but different. Sorry, just a bit sleepy. So basically, it's going to be like the same kind of thing, but this time it's going to be a minus. Oh, pardon me. So the initial number, no, the value of it, is 40,000. It depreciates every year. How much will the car be worth? And then 9, because the difference between the years. And the answer is 20,000. 816.44 pence. Okay, John bought a new house in 2002. The value of the home increases 4% each year. If the price of the house is 2,000 in 2003, how much did he pay for it? And blah, blah, blah. Basically, seems hard. That seems like we have to go back to the accelerating, but since it's still accelerating, we have to use the same formula as we did. So this one. But why is there now number like the result? So we can just put this equals, we're looking for a 1 plus boom boom boom, and then the difference between years, where is it? Over here is 13. So, and this is around 16650,735. And to leave a on its own, we have to divide this by this, and what we get is 135.129. No, that's a 27. I'm pretty sure. This. So yeah. Okay, so y equals 1,000, and this time this is more complicated because it's not in years, it's in hours, but that's going to be about the time. Right now the rate is, so b is going to be 2 because it doubles, and the number here is going to be, so look, we know it's every 20 minutes. We need to know how much in 3 hours. So 3 hours is 180 minutes divided by 20 is 9. So the answer is 9. And the way it works is basically, look, so we need to know how much it's going to be in 3 hours, but they double every 20 minutes. So that's why we just we don't do 3 hours because it's not in minutes, and it doesn't tell us how much they increase. No, they do kind of. So look, this is what, so they double every 20 minutes, right? We can do 20 times 3 for an hour. That is, no, wait. The rate, how do we get the rate each hour? Double. Okay, yeah, this is why we can't do hours, because we don't know how much they will double each hour. I mean, we could find out if you're like super smart, but I can't really think. 20 divided by 3, no. Times 3. Okay, this is why we need to have the 120 in the form of 20 minutes, like divided them. Like how much 20 minutes are there in 3 hours? That's why we need to know that number. The answer of this is 5, 12, no. Okay. Our sample contains 100 counts of bacteria. The bacteria triples every 15 minutes. How much bacteria will there be in an hour? Well, there's 15 minutes in an hour, so, and we need to know how much increase, so we use the y equals 100. B is 3 and 4. So, and the answer of this is you can do this as 81 as an easy way, and this can be, because this times this is 8,100. Then how long will it take the samples to contain 5 million counts of bacteria? So 5 million, we can put 5 million as this, and times it by this, and then we can divide everything by 100. So we have 5 times this times 3, 4. And now we need to use logarithms. So log, and log. Over here we're able to move it over here. Log. And since we need so wait, first of all we was looking for t, so how much time, like we know like the, okay, so the reason we kept the 4 for this question is because we go like by hour, right? How long will it take for a sample, and then we'll just answer in hours, because that's all in 15. Yeah, in 15 minutes. How much 15 minutes? That's why we keep the 15 minutes, but we still need to know the time. And so we have t, so the 4 was here, and we moved the 40 here, and now we want to leave the t on its own, so we divide this by 4 log 3, and so t equals 3.51. But like if you want to do that in a calculator, find out what this equals separately, and this equals separately, and then divide it with the numbers. So yeah, that's everything. Goodbye.